All right, so we're going to look at a question from True Titrations. It's one of the shorter ones that says, consider, oh no, it went away. Hang on, I was going to be able to read it. All right, considering the titration of 80 mils of 0.1 molar strontium hydroxide, it wants to know how much HCl must be added to reach the equivalence point. So let's think through this a little bit. Okay, so we are analyzing strontium hydroxide, right? So for us to get to the equivalence point, we must have the same number of moles of strontium hydroxide as we do moles of HCl, because that's what's in the problem. So it's a strong. All right. So let's start off by finding the number of moles of strontium hydroxide that it gives me. Okay, so it gives me 80 mils. All right, so that's going to be 0.08 liters. All right, because liters times moles, liters times molarity is moles. All right, the molarity of the strontium hydroxide, it gives me is 0.1. All right, so I'm going to get a mole count then of 0.008. All right, are you with me so far, Ben?
Yes.
All right. So then let's do the titration now. We want to mix them together. Now it's strong. So even though it's strontium hydroxide being mixed with hydrochloric acid, the only parts that I care about for the titration for strong items is going to be the H plus and the OH minus, which is what makes them strong. All right, and that's going to always produce water. Okay, so we know that the strontium hydroxide, the hydroxide is at this many moles, so that's the amount of moles that must go right here beneath the OH minus. This problem specifically says we're looking at the equivalence point, which means that they must both be that number. All right, so here's the battle. We are going to subtract the smaller number, which of course at the equivalence point will always zero them both out. All right, so that's what happens. That's not necessarily, we don't even need to do this part to answer what the question's asking, but just to show you, that's what the equivalence point looks like. Let's go back to the question though. It says we have 0.4 molar HCl, all right? So if we look at how it's set up, and considering that molarity equals moles over liters, all right? Let's look at the information that we're given in regards to how much HCl needs to be added, all right? So we're looking for liters, right? We're looking for how much. So we're given the 0.4 molar, so I'm just going to plug into right here. We've got the 0.4 molar, all right, equals my number of moles in order to get to the equivalence point. So the moles is that 0.008 number, moles. And we can use this to solve for liters. All right, this is that simple equation in lecture that anytime we talked about the equivalence point that we referred to. All right, so when we solve this, we're going to find out that liters is equal to 0.02, which is going to be the same as 20 milliliters. All right, I did this conversion to milliliters because if you look at the answer choices of this question, they're all in milliliters. All right, now a lot of students are getting to this number and then freaking out because they're not sure how to handle the 20 mils because it's not listed as an answer. However, the question itself in italices is stressing that this question's a little tricky because of the strontium hydroxide. Do you see that 2 right there? There's twice as much hydroxide present in this problem. And I tried to be helpful when I pulled this from a textbook and I saw the issue. So in the question, I added those italices to let you know that just like when we were studying titrations in Unit 2 and we were looking at molarity after dissociation, we have to account for this happening because there is twice as many hydroxides than meets the eye. So the trick is very simple. We'll take that 20 mils and multiply it by that amount, and you'll end up hitting your answer.